Okay, welcome back. This is a little video overview of the basic examples that are coming of Observable that are coming with the assignment 1 code this week. We already talked about the little mouse tracker here, both the event-driven version and the observable code down here. We call that the observable code. The observable had 3 distinct branches, and it's worth noting that each of those branches on subscribe, so nothing happens with these observable chains until you call subscribe, and when you call subscribe, it constructs a chain of observers all the way back to the root, to the from event. For each operator, there's an element in the chain, and they each notify each other, and there's 3 independent chains all the way back to the chain for this observable tree with 3 branches. All right, now the next example is this animated SVG rectangle. So you don't have to be an SVG guru to create these animations, either in the basic examples or for the Pong implementation that you're going to create. We give you code in this svg element.ts file. There is a class called element which wrappers an SVG HTML element. So you don't need to know about it. You don't need to know about what goes on inside this class. I'm almost hesitant to waste much time looking at the code, but you will be using the constructor, which for which you specify the SVG element, the SVG canvas to which you're adding your elements, and you will specify what type of element you want by tag name, either rect, line, or ellipse. And there's others too. You can look them up, for example, on the NDN. I'll give a link, the NDN documentation of SVG objects. You could do everything with a rect if you wanted to. So basically the code that we're doing today is enough SVG for the assignment if you want. You can go further, you can use fancy things like ellipses for balls if you want, but not necessary. All right. So I'm hesitant to dig into this. Suffice it to say that it's constructing an SVG element, appending it to the SVG object, and from then on hiding the internal element, and you can set attributes on that element using this attribute method. Or you can observe the element. You can create an observable chain from a specific event on the element. I'm again hesitant to show you this attribute method because this type definition here looks complicated. The reason there is that complicated type definition is to make it easy to use. You don't need to worry about the details of this. I don't need you to reproduce this type of type definition for such a method. What's going on is that this attribute, which is based on D3, by the way, this style of code. So this attribute functions as both a getter and a setter. This attribute method functions as both a getter and a setter. So it's a getter if you only specify the name of the attribute of the element you want to look at. So for example, you might get the width of a rectangle by saying string width here, and it would give you back the width again as a string, which you then need to cast to a number if you want to do math on it using the number function. So you would go, for example, let's just write some code. You would go myRect.attribute width, and to do math on it, you would need to go number, and then you can add to it, multiply it, whatever. Okay. So the reason for all this TypeScript foo is that when you use it as a setter, so when you, this version of the function here, so this is an overloading basically. This version of the function takes two parameters. If you specify a second parameter, then this is a setter, so it sets the value of the named attribute. And the reason for the ugly TypeScript code here is because there are two different return types for this function. This function can have two different return types. It can either return a string, in the case where we use it as a getter, or if we use it as a setter, then it returns the object itself. It returns the this element so that we can chain the attribute settings as we do down here. So here's here's our first example. When we load the page, we animate a rectangle for 1 second. Here's the event-driven version. Not actually using events, sorry, it's using a timer. So it's using a set interval. So set interval is a function built into the into JavaScript in the browser. You will have used it in the tutorial last week. And it applies this function here every so many milliseconds. So our function simply moves the X attribute of the rectangle 1 pixel to the right. It does that every 10 milliseconds. So it reads it there, casts it to a number, as I showed you before, adds 1 to it, and then sets it again. All right, and it does this until this interval of 1000 milliseconds elapses, and then we call this clear function to remove not only the animate interval, but also the timer interval, so clean up after ourselves. And that stops the animation. All right. So that's the interval version. The observable version of this code is very simple. We use our interval function that we defined in the tutorial last week to create a stream of notifications every 10 milliseconds, which we take until another observable notifies after 1000 milliseconds. And in our subscription, we apply the function, same as before, that moves the rectangle 1 pixel to the right. The next example is our draggable rectangle. So we have a rectangle, and I can click mouse down, move the mouse, and the rectangle follows the mouse until I mouse up. Mouse down, mouse drag, mouse move, mouse up. The thing to note is that I'm not simply drawing the rectangle every time at the mouse position. I'm computing an offset from the mouse position such that the rectangle is always moving relative to where we first clicked on it. So if I click on it about the center and drag, when I mouse up, the new position is still relatively centered over the mouse. Okay, so there's a bit of math to do that. Here's our event-driven code. We're not going to look at that. Let's go straight to our observable code. So as before, we grab the SVG element. So remember, we have 4 of these. The draggable rectangle example SVG element is called dragRect. We get the dragRect element, and we need mouse move and mouse up. We need observable streams for both mouse move and mouse up events. Here's our rectangle. We have only one rectangle as before, using our element about the same size as before, still the same bluish color. And now we are going to observe mouse down events that occur on this rectangle. We're getting Now we map over the incoming mouse events, which have client X and client Y. Recall that client X and client Y positions of the mouse are relative to the top left of the browser page. And we have to do a little modification. So what we're really interested in is where you click relative to the rectangle itself. So we get the rectangle X position and subtract the page position from that to get an offset, and similarly for the Y position. Okay, so now the output of this observable is these objects here with X offset, Y offset properties, and we feed those into a flat map. Now, a flat map, as we talked about in the lecture last week, flattens two streams together. So you pass in to the flat map a function which takes the incoming objects of the incoming stream and creates a new observable, or produces a new observable. So for that, we listen to our mouse move, which we take until mouse up. We map the incoming mouse move client X, client Y positions to reapply these offsets. So they'll be negative because we subtracted a bigger number from a smaller number. They will be negative, which will mean that when we finally subscribe at the top level of the stream, because that's what flat map does, it flattens or concatenates streams into a single stream. When we subscribe, ultimately we're going to get a single stream of XY objects with XY properties, which are the positions we need for the top left of our rectangle. Okay, so that's the drag rect observable. Then we give you an events version of a rectangle drawing example, which is this one down here. So we can click and drag to draw a rectangle. In this example, we can have multiple rectangles. Every time we click, we create a new, every time we left click, every time we mouse down, we create a new rectangle. And as you can see, one corner of the rectangle is always fixed to where we clicked at first, and the other corner of the rectangle follows the mouse position. Okay, so we give you the event-driven logic for that. The observable version will not be so different to the observable version of the dragging example. The big difference is that on every mouse down, we are going to create a new rectangle. So we're going to create a new rectangle, probably in a map, and pass that through to the flat map, where we will compute the size, the width, height, as well as just the X and Y position of the remaining of the rectangle. And then we're going to set all four of those properties in the subscribe at the end. So very similar to this one, but with a rectangle object that we need to pass right through to the end, because remember, on the rectangle drawing example, we will have multiple rectangles. In our subscribe, we need to specify which one we're talking about, which one we are adjusting. All right. That is your first task this week then, is to implement the draw rects observable example. The other function that you will be implementing is a draw and drag rects observable. So it's essentially drawing a rectangle and then adding observables underneath that to handle subsequent drags. You can, if you like, refactor it so that you get two functions that you can compose together, one for drawing and one for dragging, and refactor those out into a draw and drag function that will make this function almost trivial. So that's an example of how observables can be composed together in a very reusable way. One gotcha on this example is described here. So you'll need to solve how to drag a rectangle without starting to draw another rectangle at the same time. So to stop the event propagating, you would, for example, add another subscription to your mouse down on that initiates a drag. And so mouse downstream might be called that, and you would go subscribe, and you would have a function which expects a mouse event, the mouse down, and you would call that mouse event's stop propagation method, and that will stop then other observers firing in response, other mouse down observers firing in response. Okay, so that's enough to get you started, hopefully, and you will hopefully gain lots of, you'll hopefully get everything you need from these basic examples to get you started on your Pong implementation, which you will place inside this function here in the pong.ts file, and it won't be, hopefully, you can make a basic Pong implementation using everything that you've seen in these basic examples. I hope that some of you at least will go further and extend Observable perhaps with other operators to create richer interaction, more elegant interaction, and I hope that some of you will get really creative and create cool games that are not just Pong, but perhaps your own creations or mashups of other games. And I hope you have fun. All right, good luck with that, and see you in the lectures.